I am Stefano Amaducci. I am a professor of field crops and agronomy at the Department of Sustainable Crop Production at Università Cattolica del Sacro Cuore. Here we are at the experimental agrivoltaic plant of our faculty. We have an extensive experience on agrivoltaics. First we started with our research on the effect that agrivoltaics has on crops. So we developed a modeling platform to simulate the effect that the shading that you can see here under the agrivoltaics has on the crop is a dynamic shading, because of course in this case both the sun moves and also the panels, so the dynamic of the shading changes from minute to minute and hour to hour, so we can simulate how the effect of the shading in different times of the day and on different crops has on the yield of the crop but also on the quality of the crop. So all these has been in silico so far, and now finally that we have just very recently inaugurated our agrivoltaics plant, we can perform all the trials to validate but also to calibrate our model. So our main scope in our activity, which is also part of the Value4Farm project, is the development of a modeling platform that can be used to optimize the design and the management of the agrivoltaics plant. By optimize the design, we mean running scenario analysis with which we see the effect of different types of agrivoltaic systems. So this system is a biaxial systems. You can see that the panels are quite high. It's about 5 meters above the soil. The panels rotate following the sun on 2 axes, so there is almost a perfect tracking of the sun, which of course is valuable when you want to maximize energy production. But we can also decide to move the panels anti-tracking, so to reduce or even to eliminate the shading on the crops, in particular phenological phases of crop growth, in order to increase, for example, crop yield. So we have different objectives, different KPI that we can calculate, and on the basis of our objectives, which can be reach a certain amount of yield under the crops or obtain a certain level of economic return from the combination of energy production and crop production, or for example to define a certain level of water saving, because the crops under the shade save water or consume less water per unit of product. So we have all these different KPI, and so we can define which is the best design and the best management, so in terms of movement of the panels. Experimental or demonstrative, because agrivoltaic system is very close to our university, is really across the road. So it's a fantastic opportunity for the student to take part in our experimental activities that we carry out both on let's say industrial crops like this one. This is soybean, and then in the next line of trackers we have sorghum, but next crop is going to be wheat. We're going to also grow maize, but we also have horticultural crops like potato, tomato, spinach, just to cite some of the crop with which we have the intention to work this year or next year. Then we will also have other type of crops in the future. So this is a big opportunity for the students, but it's also a great opportunity for our faculty, our university, because thanks to this plant we're going to produce about 60% of the energy which is required on campus, and 80% of the energy which is produced by these panels is self-consumed by the faculty, and the rest of the 20% is consumed by our student facilities, which are with which we have formed an energy community. So this is a perfect, let's say, facility for our campus to produce clean energy, to do agricultural experiments.
Hi everyone, my name is Joao Vitor Paravidini. I am a PhD student in Università Cattolica da Sacro, Cuore, specialized in ecophysiology of crops. Our main goal with this project is to define good management practices for several crops, like soybean and sorghum you can see here, but also potato, spinach and tomato. Now we are running an experiment with potato in pots because we need to check the phenological stages the potato are achieving, especially the tuberization, the start of the tuberization. Because we want to apply a strategy named anti-tracking, which means when we will move the panels in the opposite way of the sun during a certain time, because this strategy of course will reduce the energy production, but also can significantly increase the tuber production. So in this experiment we divided our plants in 5 sectors based on the gradient of shading the panels can provide, and this combined with the usage of a lot of sensors that can measure, for example, radiation intensity, moisture and wind, can make us able to fully understand how the agrivoltaic condition and how this type of strategies can increase and modify the production of this crop of interest. Thank you.
If you see this from a perspective instead of a farm, the same can apply, of course, because farm needs to decarbonize also through the use of renewable energy, but also, and this is also part of the activity that we do in our research, is to try to decarbonize the whole production chain of agro-industry. So we collaborate with agro-industries, so which transform the produce from the soil. Just to give an example, for example, in our region we have a lot of industrial tomato, so we collaborate with the industry that transform tomato to establish agrivoltaic system in order to use the energy produced by the photovoltaic panels to satisfy the energy requirements of these industries. So which is another example on how agrivoltaics can be integrated in agricultural activity. In the specific case of our campus, we are in a peri-urban area in which there are a lot of industrial facilities, which can be another, of course, important element in the use of the energy that we use with agrivoltaics. But in peri-urban agriculture, there is also the production of a lot of crops which benefits from the shade, like for example lettuce or many other horticultural crops that can benefit from the shade of the agrivoltaic. So these are just different examples on how agrivoltaics can benefit agriculture, but also the process of decarbonization of agro-industry.